Okay, so we're going to show angle-angle similarity. We have two triangles, and two angles in one triangle are congruent to two angles in the other triangle. We need to then show that the triangles are similar. Now, to do this, we need to understand what similarity actually means. So what similarity means is that all the angles are congruent and the sides are in proportion. So the first thing I'm going to say immediately by third angles theorem, I'm going to have that third angle congruent to the third angle in the other triangle, right? And you just need to understand what third angles theorem is. So now I have that all the angles in one triangle are congruent to all the angles in the other triangle. I need to show that this is going to imply that the sides are in proportion. So we still need to show, right? We want to have a goal in our minds. So we're going to write down what our goal is. We need to show that the sides are in proportion. So that way side AB over side DE is equal to side BC. The length of B from B to C is equal to, or over the length from E to F is equal to the division of the length of AC over DF. And this is what we need to have. Now, in order to do this, right, we're going to start off with saying if the two triangles were, so if the two triangles are congruent, or if one side of the triangles are congruent to any other side, then the two triangles will be congruent, right? Because then you would have angle side angle. So you know right away that one triangle will be bigger than the other triangle. Or you could say that, again, let's just go through this argument with the words and understand these words because it'll just help us. If one side of one triangle, with what we have these conditions, right? And we just showed this, right? If one side of triangle ABC is congruent to some other side in triangle DEF, then you immediately know that the two triangles are congruent and then therefore they're similar. So we must have it where all the sides of triangle ABC are different from all the sides in DEF. And that one triangle is actually bigger than another triangle. So what I'm going to do is I'm going to say ABC is the bigger triangle. And I'm going to draw this like this as best as I can. And I have here triangle A, B, C. Now there's a few ways to go from here, but what I'm going to do is I'm just going to say right away that triangle DEF, right? What do I know? I know that angle B is the same thing as angle E. So right here, what I can do is overlap DEF right on to triangle ABC. And again, we know, or we're just kind of going off of the idea that ABC is bigger than DEF. What we know is we know that A is the same thing as D, and we know that F, we just showed F is the same thing as C. And of course, we started off with the idea that that B is the same thing as E, right? That's how we were able to overlap. Now, the argument that I'm going to make here, I could have easily made by overlapping, instead of overlapping onto E and overlapping B and E, I could have overlapped onto F and C, and it would have looked like this, right? So I'm drawing this is now where D would be. Yeah, D, E, and then F and C would overlap. And I can make the same argument. I would do the same argument. It would be a symmetrical argument over there. And this is going to come into play later. But right now, let's just understand that I can overlap DEF as I have it right here. And I'm going to show this one here. going to show that equality. So the way I do this is, the first thing I'm going to do is I'm going to draw this line right here. Okay? And we're going to start looking at areas. So if we see this, we got to look at two triangles. So let's look at triangle AFE. Okay? And let's also look at triangle DEF. And there's a relationship with these two triangles, because what you can do is if you look carefully, what I could do is I could draw an altitude or a height from F in both of them, where I call this height 1, right? So if you want, right? Okay, so if it's the case that we have this as H1 here, right? The area of DEF is going to be equal to this height times DE, right? Or whatever that height is, by 2. And if you look carefully at AEF, right, you should see that this is also point B up here, right? And that's relevant because I covered it up, but this is AB times H1 by 2. And then what you do is you divide these two areas. So you can say AEF, the area of triangle AEF, divided by the area of DEF. We get a familiar ratio. And take your time, make sure you see why this is AB over DE. Okay, make sure you see that you can do the division of fractions. This divided by this, or sorry, the other way around. Okay, so it's this one divided by this one. Okay. All right, show why, if I divide, that's the other way around, but okay. This is equal to, right, this division is equal to AB over DE. Okay, and you should see why. You should know how to divide the fractions. Now, if I look again, if I say, okay, here's DEF again, right? But now this time I want to look at the altitude from here. So let's say this is the altitude. Let's say this is a height, and that this is H2 now, this length right here. And I look at this triangle, right? Okay, and I'm going to call this triangle DEC. Okay, so this pink triangle is DEC. I'm going to use E. And then DEF, right? Or should I use, no, I should call it DBC. Why should I call it DBC? Because in this one I have AB over DE. That's a good thing, because look what I'm trying to prove, remember. I'm trying to show a relationship between AB over DE. And I have that here, right? Now I'm going to get BC over EF. So how do I get a ratio of BC over EF? Again, looking at these other triangles, or this other triangle, DBC. So DBC, let's look at the area of DBC. It's this H2, right, the height, times the base. But the base of DBC is BC. So then it's over 2. And then the area of DEF is H2 times BF or EF. EF is the one I want to use again, because again, I want to get that other, is it EF that I want to use? Yeah, it is, EF. over 2. And then if I do this division, right, if I do the division again, right, I'm going to get that DBC over DEF equals BC over EF. And this is good because now you have these two ratios that we're investigating. And we should see that, right, what do you have at this point? You got this, and we got this, right? Now, I want to ultimately show that this equality exists, that this one is the same as this one. So then if I show this is the same as this, then I'm done. So in order to do this, right, I'm going to say, okay, what do I need to show? Let's look. If this, the area of DEF is in the bottom of both of these already. So I only need to show that this is the same as this. And now we just sit here and we make this argument. So now let's look. I have AEF. Let's look at triangle AEF and let's look at its area. AEF is this triangle right here. We should see that it's the area of this triangle plus this triangle. So it's the area of DEF plus the area of ADF. Similarly, let's look at the other triangle that we care about. Let's look at triangle. What's the other one we care about? So we want to show what? AEF is the same thing as DBC. Because if I show that, then this equals this, which means that this equals this. And I've shown this equality, which is what I ultimately want. So if we look at DBC, this triangle right here, we should see again that it's DEF, this triangle, the area of this triangle, plus the area of triangle DFC, this triangle right here. So now I have that DBC is equal to DEF plus DFC. And now let's look what we have. So now, after we have this, right, well, DEF is the same thing as DEF. So this is the same as this, right, these two areas. So if I'm trying to show these two are the same, all I need to show is that ADF is the same thing as DFC. So let's look at DFC. It's equal to DFC, right, is right here. If we look at this, right, we should see that DF times this height right here, and let's call this H3, right, is the area, divided by 2 is the area of DFC. DF times H3 over 2 is DFC. But then if you look now very carefully at ADF, right? Where's ADF? ADF, right? If we look at this, right? Again, if we take DF as a base, then this is also H3. And the reason for that is that this line is parallel with this line, and perpendiculars between parallels are congruent. So the only thing that's tricky is seeing that this length is the same as this one, and they're both H3. And if they have that, they share that base DF. So I have ADF is equal to DF times h3 over 2. And it's clear that then these two things are equal. And then if these two things are equal, then these two things are equal, right? Because this is the same as this. So clearly then this is going to be the same as this, which means that these two things are the same. And then if these two things are the same, then that means that this is the same as this. And then that means that this is the same as this. And we can say by a whole bunch of substitution, everything I just said is, let's say, a substitution argument. By substitution back, we get AB is equal to, over DE, is equal to BC over EF. And now what we're going to say is, we're just going to say one last piece here to prove this, because now I showed these two are the same, right? I could show this equality, or maybe that these two are equal, okay, which is all that I would need. Because if I show this equality, then everything is equal. This equality, BC over EF is equal to AC over DF, by just moving this triangle into this corner and making the same argument. I would draw this, and then I would make an argument of the heights and so forth. I would draw it like this, right? And I would just shift the argument, okay? And it would show the other equality. We can make a symmetric argument to show other equality. And then we'll say and to show other equality, and have that this is true, and have that AB over EF equals that one we showed, BC over EF is equal to AC over DF. And we will have shown that the sides are in proportion, which allows us to show, or which means that we've shown the angles are congruent and the sides are in proportion. Triangle ABC is similar to triangle DEF. And now you're done.